Good morning, everybody. Let's see if we can get the slides going. It's actually really cool that I'm the first person to talk this morning, so I can give you ideas to think about for the rest of the day. But I need my slides because just explaining it abstractly will not work. Perfect. Okay, so practical proof of access, or as we like to call it, POA. Yes, there is another POA, but this is the good one. Very quickly, I very deliberately did not make any fancy diagrams or something like that. This is just to recap. The next slide is what's important. So this is what we do today. Every single miner does exactly this thing. So they run what we know as PC1, which is they run for 2 hours or 5 hours if they're using supranational. They generate an incompressible, unique, verifiable, sector-sized stream of bytes. We call this thing the sector key. It is supposed to be slow by design. Then what they do after they have this, they add the sector key and the data. This is very fast. Effectively, given all the other latencies, assume that it's instant. And then they built a Merkle tree allowing for random periodic challenges. So we have what we call commitment, which is a single hash. And then we make challenges against this thing plus the data. And the person being challenged, the operator of this node, must be able to return a response depending on the type of challenge. One challenge is 30 minutes long. The other challenge is 30 seconds long. This allows for two types of verifications of all the storage that people have. All the sectors, every 24 hours, are being validated using this thing. And then one sector from all the sectors you have, every time you win a block, in order for you to be eligible for this block, you need to satisfy a winning post, which is 30-second window. It's all you have.
What's PR?
Block reward. Block reward, sorry. So whenever you are selected to win a block, you have to do the response within 30 seconds for one sector, and all your power that determines whether you're eligible for a block or not is based on 30-minute windows that you have to do every day. Okay, this is what we do today. The proposed change, which Kuba and I came up with, and Luca wrote up in a very nice Notion doc, is this. So we still do the first step exactly the same. Still spend the minimum 175 hours, more like 2 hours. Then we build a proof only over this incompressible thing. Then we again put together the sector key and the data, and then we built another proof on top of that, just like before. So this is what we had here, and we do exactly the same thing. So all we do is in between these steps, which are exactly the same, we create one more challengeable stream. And then everything else remains the same, but at the end, every time that we challenge, we do the challenge twice. So you have to submit not one window post and not one winning post, but two of them. One over this and one over this. What does this prove whenever you give a proof of space-time like this? You still have the opaque slab of bytes, which is hard to recreate, and we know that you expended the time to do it. But you also now prove that you, as an operator, have continuous access to this part. Because otherwise, there is no way for you to respond to this challenge in the time allotted. Now, continuous access is very important because it's not that you are necessarily storing this yourself. You can share a copy with others, but the point is that within the 30-minute and 30-second windows, you are somehow being able to get it. So, the cool part. So what does proof of access actually allow? It gives us hard on-chain cryptographic proofs that we have fast access to clear data. We're not talking about a replica that you need to unseal and maybe they'll unseal it, maybe not, so on and so forth. The actual data was accessed at this time. If we implement this in any variation of that, no matter how we do it, resnapping comes for free as a result of that. Because today resnapping is very difficult to do for security reasons, but because now we record the sector key, COM-K on chain, and the sector key is always available, we can just keep resnapping over old data without needing any access to it. So that's cool. Operational cost reduction. Because now we have cryptographic proofs that who has what, the SPs between themselves can decide how many replicas of the clear data between themselves they're going to keep, because if they have too few of them, they are all going to get slashed at the same time if they lose access to that. But at the same time, it's not rational for them each to hold a copy on their own, and it opens a complete off-chain market, or maybe on-chain market, it doesn't matter, for the participants to figure out how they are going to maintain redundancy. And the last thing that this can do is it can very substantially close the gap between the sector onboardings. So today we talk about like adding data is like extra gas and so on and so forth. Resnapping is a very big problem that we have to kind of incentivize people to do and so on and so forth. If we implement this just the right way, and we really need to discuss like how we can do this with input from CryptoEcon team and so on and so forth. But if we implement this right, we can make the on-chain footprint of adding CC, data, or a snap exactly the same. So no matter what kind of sector you're onboarding, everything is exactly the same in terms of gas, in terms of operations, and so on and so forth, which closes the gap which Fill Plus was originally designed to fill. So this also gives us an option to rethink from first principles, okay, now the gap between CC and doing all the way to data is so much smaller. Is Fill Plus in its current form necessary, or we can do something better? That's it. Questions?